Hello everyone, I am Anil Bharate from Department of Computer Science and Engineering, BLDA CET, Vijaypur. In this video, I am going to explain properties of functions. Now, there are few theorems which will cover the properties of functions. Now, theorem number 1 is let A and B be finite sets and f is a function from A to B. Then following are true. If f is 1 to 1, then number of elements in set A must be less than or equal to number of elements in set B. And second result, if f is on to function, then number of elements in B are less than or equal to number of elements in A. If f is 1 to 1 correspondence, then number of elements in A are equal to number of elements in set B. And last one, if number of elements that is in A are greater than number of elements in B, then at least two different elements of A have same image under F. Now let us try to prove this theorem or these results one by one. Now before that, let us try to understand what is image and what is pre-image. See, if there are two sets A and B and we have function, now A and B, A is mapped to B. Here B is image of A and A is pre-image of B. You need to remember this. And a relation to be a function, no elements should be left in A without mapped. Say for example, say there are three elements 1 2 3 1 2 3. One is mapped to this one, second one is mapped to this, and even second one is mapped to third one. So this is not function because single element of A cannot be mapped to B. This is one reason, and another reason is this is empty element, this is unmapped element in A, then it cannot be a function from A to B. You remember this, while proving it will be helpful. Now consider first one. If f is 1 to 1, before that let us have number of elements. Let us assume that we have number of elements in A as n and number of elements in B as m. Now suppose if f is 1 to 1, then images of elements of A, they are namely A1, A2, so on n. So they are n in numbers. Total images of all the elements, they are n in number because it is 1 to 1. Because say number of elements in A are n, then there must be n mappings. So all these images belong to B. They must belong to B. Say we are mapping from A to B, so the number of elements, they must belong to B. Therefore B must have at least n elements. See, when we are mapping 1 2 3 up to n elements from A to B, and there are n, and it is 1 to 1 function, so 1 to 1 means there are no multiple mappings 1 to 1, so up to n. So in B we must have at least n number of images. So it means that number of elements in B must be greater than or equal to n. At least n means greater than or equal to n. But what is n actually? It is number of elements in B. So number of elements in B are greater than or equal to number of elements in A. And it is nothing but again number of elements. It can be written as like this. Hence it is proved. That is the first result. Now let us prove second result. If f is onto, then B is less than or equal to A. Well, see, when a function is onto, or else before that let us try to understand what is onto in brief. Well, now for every image, in B, there must be only one pre-image in A. It is onto function. Now when we have n number of images, then there must be at least n pre-images in A. If we have extra element in A, it will not be a function. So what we can say is number of elements in A, they must be greater than or equal to number of elements in B. That therefore we can write it as number of elements in B is less than or equal to number of elements in A. Okay. Well, so for 1 to 1, it is A less than or equal to B. For on to, it is B less than or equal to A. Now third result, if F is 1 to 1 correspondence. What is 1 to 1 correspondence? It means that a function must be both 1 to 1 as well as on to. So therefore what we can write is, we have already A less than or equal to B and B less than or equal to A. So when both are true simultaneously, then there is only one possibility, that A must be equal to B, or I can say number of elements in A are equal to number of elements in B. So that proves the third result. Okay. Now let us try to find or prove the fourth result. If number of elements say are greater than or equal to A greater than or equal to B, then at least two different elements of A have same image under F. Now I will write it here, somewhere here. Well, what it is, if number of elements in A are greater than B, let us have 1, 2, 3 elements in A and only 2 elements in B, because it is given. And observe that it is greater than, not greater than or equal to. So I have written greater than. There are 3 elements in A and there are only 2 elements in B. Now what is? At least 2 different elements of A have same image under F. Now see, when I map first element to this one and second element to this, now there is one extra element in A. If I leave this element extra or unmapped, then it will not be a function. So to be a function, it must be mapped to one of the, yes, if I mapped it with this is possible function. Two elements of A can be mapped to single image, but vice versa is not possible. So that's what, whenever we have number of elements in A greater than B, then at least two elements of A must be mapped to single element of A, and hence proof. Okay. Now second theorem, suppose A and B are finite sets having same number of elements. See, both are having same number of elements, say 3 and 3, and F is a function from A to B, then F is 1 to 1 if and only if F is on to. See, we have both, both sets have same number of elements, 3 and 3. If at all it has to be 1 to 1 function, before that it must be on to. Say, yes, every image in B must have a different pre-image in B, that is on to. On. Whenever it is on to, then it must be 1 to 1. Already I have discussed in previous video that the difference between on to and 1 to 1 is, in case of 1 to 1, we may have extra elements in B. See, this is 1 to 1. We may have extra element in B. But in case of on to, there cannot be any extra element in B. All elements must be mapped. All elements of B must be mapped. But in case of 1 to 1, it is okay if some elements of B are left unmapped. That is second theorem. Now let us find the formulas, or let us discuss the formula for how to find number of 1 to 1 functions and on to functions. If we have m as number of elements in A and n as number of elements in B, suppose let us think Now, number of one-to-one functions and from A to B, that is important, is given by permutation of n comma m, and formula will be n factorial divided by n minus 1 factorial. By using this formula, we can find number of one-to-one functions from A to B. And number of onto functions from A to B is given by P of n comma m, and it is given by summation of k is equal to 0 to n minus 1 raised to k into bracket nc n minus k and n minus k raised to m. You need to remember these two formulas. The first example I'm going to solve. Let A and B be finite sets. There are two sets, finite sets. If there are 60 one-to-one functions from A to B and number of elements in A is given, it is 3, then what is B determinant? That is how many elements are there in set B, that is to be found. So how to find the number of one-to-one functions? The formula is this, P of n comma n. So let me write it here. Solution. First write the given data, P of n comma n. It is given number of one-to functions is 60. And number of elements in A is also given 3. Number of elements in B is not given, that is the question. So P of n comma n, the formula is n factorial divided by n minus m factorial. We know P of n, it is 60 equal to n factorial is not given, n factorial is as it is, then n minus m. N minus what is m? M is 3 factorial. Now it can be written as n factorial can be written as n into n minus 1 into n minus 2 into n minus 3 factorial divided by n minus 3 factorial. Now these two terms n minus 3 factorial get cancelled, then it will be 60 is equal to n into n minus 1 into n minus 2. Now if you observe, if you get n is equal to 5, then this n is equal to 5 will give you LHS is equal to RHS. Therefore, number of elements in set B is equal to 5. You can make use of that formula and you can find. Well, second example is given. Let A is equal to, this set is given, there are 7 elements, and B there are 4 elements. Find the number of onto functions from A to B. Now it is straight away. Now let us find the formula. Let us get the formula first. It is summation of k equal to 0 to n minus 1 raised to k into bracket nc n minus k, then n minus k whole raised to m. This is the formula. But under solution, the given data is, say, m. M means number of elements in set A. 1, 2, 3. There are 7 elements. N is given. N is 4. Now let us find the number of elements in B. So it is P of n comma m is given by this formula, k equal to 0 to n minus 1 raised to k n c n minus k whole raised to m. Now let us replace this k values one by one. Minus 1 raised to, first time k value is 0, means that nc n minus 0, n minus 0 raised to m is 7, and n is, okay, it is 4. Let us replace n by 4 plus, then second time value of k will be 1, so minus 1 raised to 1, 4c 4 minus 1, then 4 minus 1 raised to m is 7, plus minus 1 raised to next it will be 2, then 4c 4 minus 2 because k value is 2, 4 minus 2 raised to 7, plus minus 1 raised to next time value of n will be 3, then 4c 4 minus 3 into 7, then plus minus 1 raised to 4, because value of n is 4 up to 4. So 4, then 4c, 4 minus 4, 4 minus 4 into 7. Now if you simplify this, at the end you will get answer as 8400. You just simplify this, apply the formula for NCR, like that. NCR formula is n factorial divided by n minus r factorial into r factorial. If you simplify all these terms, you will get 8400 as the answer. Thank you.